Hi there, grade 11s. Welcome to the channel. On this lesson, guys, we're going to focus on this Limpopo past paper. So this is the final examination for the year 2025. Okay, so now this is the question that we're going to look at, which is question 3. And I'm going to guide you guys, make sure that you understand how to approach this question using the correct method and exam techniques. So if you find this lesson helpful, please don't forget to like the video, subscribe to the channel, and turn on that notification so you never miss the future maths and science lessons. Okay, now let's get started. Let's first read the statement. What is the statement saying? Consider the triangle PQR drawn below. PO, so we are given the equation of PO. So I think it's best if we draw that line. So this line has the equation y, it's equals to what? 5x plus 9. Okay, while PR, this equation has the equation 5y plus x minus 19. This is 0. Okay, so now let's go and see what are the questions saying there. The first question they're asking you to show that the coordinates of P are -1 and 4. So the x value, that's -1, the y value, that's 4. We need to prove to find the coordinates of P. So what I'm going to look at P. When I see P, I know that P is the point of intersection for these two equations. Is the point of intersection. You need to ask yourself, how do we find the point of intersection? So to find the point of intersection, we're going to take these two equations, solve them simultaneously. So what I'm trying to say, if I have the first equation as y to be equals to 5x plus 9. Let me call this equation 1. And we have 5y plus x minus 19. It's equal to 0. Let's call this equation 2. So we have two equations. What I'm going to do, already we have one equation as, what is this? We have one equation as one variable there as subject of the formula. So the aim is to sub in, we can sub in that equation 1 into equation 2, meaning that where there's y on equation 2, we can definitely put that 5x plus 9. So this becomes 5, where that's why I'm going to put 5x plus 9, close the bracket, plus x minus 19. This is 0. So the aim is to make sure that whatever equation that we are working on, there's only one variable, which is x. So let's multiply out the bracket, group the like terms, and add them. So I'm going to multiply everything inside this bracket by 5. So this will be 5 times 5, that's 25x. And then 5 times 9, 5 times 9, that's 45. So this will be plus 45. We still have plus x, we still have minus 90. Okay, so now when you look at this, I can say 20x, 25x plus that x, which is 26x. Then let's take 45 minus 19. So we're going to take 45 to minus 19. This gives us positive 26. And this is just equals to 0. So to solve for x, this will be 26x. Let's move the 26 to the other side, because when it's on the left-hand side, it's positive. When you bring it on the right-hand side, it becomes negative. So this will be negative 26. So this will be negative 26. Divide both sides by that 26 to isolate what? The value of x. So the 26 cancels. This leaves us with x, it's minus 1. So we've proved that x is minus 1. That was the plan, right? To prove that the x coordinate is minus 1. You need to go back and find the y value. You don't have to stress about the y value because already you know that y it's equals to 5x plus 9. Already we know the value of what? We know the value of x. So where does x? We can substitute that minus 1, and this will give us, when you punch that on the calculator, it should give you 4. So that's 5 times minus 1. That's minus 5. It's going to be, let me see. Okay, I think I made a mistake here. This should be plus 9. Okay, so this will be plus 9. So this is the same as minus 5 plus 9. Therefore, y is 4. Then we just prove that the values of p are minus 1 and 4. Then you move to the next question. The next question says that show that PO is perpendicular to PR. What do you know about the gradient of perpendicular lines? If two lines are perpendicular, so to answer this 3.2. So to answer this 3.2, we need to show that PO is perpendicular to PR. If we take the gradient, of PO, then you multiply that by the gradient of PR, you must get your answers minus 1. So if that's the case, therefore you can conclude and say they are perpendicular. So let's go and find the gradient of PO. You don't have to do any calculations because we can find the gradient of PO by looking at the equation. So remember, the equation of PO, which is this equation, it's in the form of y, it's equals to mx plus c. So what is your gradient? Is the coefficient of x. Whatever number that you have in front of x, that's your gradient. So the gradient of PO, that's 5. So maybe you can also note it down for the exam and say the gradient of PO, that's 5. So 5 multiplied by the gradient of PR. So the equation of PR is in this form. Ladies and gents, this equation is not in the correct standard form. We need to put it in the correct standard form, which is this form. Then we'll know what is the gradient of this. So we need to solve for y. So the equation is given as 5 y plus x minus 90. This is 0. Let's make y subject of the formula. I'm going to move everything to the other side, which gives us minus x plus 19. Let's divide everything by 5. Therefore, the standard form is minus 1 over 5x plus 19 over 5. So look at what is the gradient of PR. This is the gradient of PR. This part here, that's the gradient of PR. So now that you have the gradient of PR, so the gradient of PR is minus 1 over 5. So we just have to come back and substitute it on that equation, see what we get when we multiply this. So this will be times minus 1 over 5. So when you multiply this, they give us minus 1, right? So the product of the two gradients is minus 1. Therefore, we can conclude and say PR is perpendicular to PO. Then you'll definitely get all the marks. That's how easy 3.2 is. Okay, so on 3.3, they are talking about the hence. Hence means that use whatever answer that you got on top to calculate the area of triangle PQR. Hence or otherwise. Hence means use what we got on top. Okay, so what I'm going to do when they say hence, I think we can use, if you look at this, let's do this. I think it's best if we find if this is my PR. Let me quickly have this is my PR. Okay, let me this line here, that's my PR, and maybe we can get PQ, which is this line here, PQ. Because they said hence, I need to use this point. So find can we find the two? Because remember, if they are looking for the area of the triangle, what is the formula for area of a triangle? I'm just going, I think it's best if we start it from that part. So uh, the area of triangle PQR, it will be equals to half. I'm going to take that PQ, it's half of PQ multiplied by PR. So we need to find the length of PQ. Oh, this makes sense because this is 4-mark question, and find the length of PR. So the examiner here is testing if you can use the distance formula to find the length of these two. Let's start with the first one. I'm going to look for PR using the distance formula. Remember, the distance formula is going to be x2 you minus x1 everything squared plus y2 minus y1 everything squared. So we're going to use these 2 points for P and R. So I'm going to write my points down, P, R, so that we can identify which one is your x2, which one is your x1. So if I say P, the coordinates of P is minus 1 and 4. And then the coordinates of, this is for PR. The coordinates of R, that's 4 and 3. Then I'm going to name my points. P comes first. I'm going to call it my X1, Y1. Then this will be my X2, Y2. Then now I can do the substitution on this equation. Let's see what we get. Where there's x2, we put 4. Minus x1, it's minus 1. We should put it inside the bracket and everything squared. Your y2, that's 3. Minus your y1, that's 4. Everything inside the bracket. So if we punch this on the calculator, let's see what we get. What is that equals to? So this is the root of 4 minus into minus 1. Close the bracket twice, please. Make sure that you don't make mistake on that one. And 3 minus 4. What is this equals to? Don't forget to square. This is root 26. So I'm going to say this is the root of 26. So this will be root 26. I think it's best if we leave it like that, right? So we still have a mission, which is to find the other distance, which will be the distance of PR. So let's continue and look for that distance of PR. So PR, oh, we already have PR. Let's look for PQ. So PQ will be the root of x2 minus x1, everything squared. Then y2 minus y1, everything squared. So I'm going to use the same method so that I don't make mistakes, okay? So I know that my P, the coordinates of P, that's minus 1 and 4. And the coordinates of Q, it's minus 2 and minus 1. This is my Q. Okay, so let's quickly do the substitution. But before that, let's name PQ. P comes first. Maybe this will be my X1, Y1. And this will be my x2, y2. Let's do the substitution. So PQ will be, let's see, x2 that's minus 2, minus x1 into minus 1, everything squared. Then y2, that's minus 1, y1, that's 4, everything squared. So let's just put this on the calculator and see what is that equals to. So this is minus 2, minus into minus 1, everything squared. Then we have minus 1, minus 4 squared. And this also gives us the root of 26. So these two distances are equal the root of 26. So we have the length of these two sides, right? So we can definitely calculate the area. So if you still remember on top, we said that the area of that triangle PQR, it's half the base times the height. But in this case, it's just PQ multiplied by PR. So you just have to substitute your area. It's half of that PQ, which is root 26, and root 26. So this is like saying 26 times 26 because the square root cancels. But let's just use the calculator now. Just gonna put this on the calculator. 1 over 2 into root 26 into root 26. Close the bracket. So this gives us 13. So the area is 13, but it's going to be 13 square units, okay? 13 square units, because we don't have any measurements or the length, if it's centimeter, millimeter. So if it is not given, we just say 13 square units, just to show that we are referring to the, what? The area. Okay, 3.4, determine the equation of the line parallel to QR passing through P. So when it passed through P, this tells you that for 3.4, this tells you that we use the coordinates of P, which was minus 1 and 4. So this line, it passes through, and then when lines are parallel, they have equal gradient. So the gradient is, we're going to use the gradient of QR. So what is the gradient of QR? We need to first find the gradient of QR. When two lines are equal, they have equal gradient. So the gradient of QR will be y2 minus y1, everything over x2 minus x1. So I need the coordinates of q. Q is minus 2 minus 1. And R, that's 4 and 3. So this will be 4 and 3. So you need to identify which one is your x1, y1, which one is your x2, y2, so that it becomes more easily to do the substitution on this gradient formula. So where there's y2, we put 3, minus where there's y1, you're going to put minus 1. Everything is divided by your x2, which is 4, minus your x1, that's into minus 2. Please make sure that you put it inside the bracket. So on top, we just have 3 plus 1, that's 4. On bottom, 4 plus 2, that's 6. And this gives us 2 goes into 4 2 times, 2 goes into 6 3 times. So the gradient is what? The gradient of QR is 2 over 3, which is the gradient that we're going to use on this equation. So you just have to take this gradient, substitute it on that equation. So this becomes what? Y, it's 2 over 3 x plus c. So to find c, you're going to use the point, the given point. So if you look at this, they said it passed through what? P. So we're going to sub P, which is minus 1 and 4. This is your x, this is your y. Where there's x on this equation, we're going to put minus 1, where there's y, you put 4. So this will be 4, it's equal to 2 over 3, where there's x, you put minus 1 plus c. So now we're going to bring this guy to the other side. It's like 4, it's equal to minus 2 over 3 plus c. So the value of c is just 4, we add 2 over 3. 3 times 3, 3 times 4, that's 12. Plus 2, that's 14 over 3. So c will just be 14 over 3. That's the value of c. So what will be the equation? From this equation here, we can definitely substitute the value of c. So when you substitute the value of c, therefore the answer will be y, it's 2 over 3x, then you add that c, which is 14 over 3. So that's the equation of the line that passed through Pn is parallel to Qr. That was an easy one. Okay, so now I need you guys to look at this question. 3.5, this is for 2 marks. If you get this right, I'm just gonna give you the answer, and I need you guys to fight with 3.5. Once I start seeing comments, this proves that you finished this video. So 3.5 says determine the coordinates of S if PQSR is a parallelogram. Okay, so I'm going to give you guys the answer. I want you to try and work around this question. So on 3.5, the coordinates of S should be 3 and minus 2. The coordinates of X should be 3 and minus 2. So this is the answer. You need to go and research how we got to that answer. If determine the coordinates of S if PQ SR is a parallelogram. If you get this right, maybe you can try to leave a comment if you got it right and which method you used. Okay, and if you find this lesson helpful, make sure you join the family, subscribe to the channel, and I'm looking forward to see you guys on the next lesson. Thank you very much for watching.